My name is Herman Labuschagne. I work for Impact Engineering as contract manager. So I'm basically in charge of all the site activities. Where do I begin? With DCC, our issue there was we all virtually had zero space, none. But we were told that from the outset. It was one of those projects. I think we soon realized that we would have to create a sort of model or sort of a chessboard where we could lay the individual arch pieces, obviously down to scale, lay them on the chessboard and shovel them around, see how we could place them on site before we even did that. See where we could place mobile cranes, so we could sort of get the best fit scenario before even attempting to go on site. So that was done quite some time before we actually got onto site, and it was initiated by Quentin Nitt, one of our managers at Impact. He's got a great insight when it comes to these kind of things. So he started that, and I took the idea and ran with it, and that was one awesome idea because it soon showed us that any other way would have potentially caused disaster. So the chess pieces was laid out. So we virtually knew before we started where every single arch would be laid, where the cranes would be positioned, and then finally how the arch pieces would be lifted in the air. None of which was just a simple vertical lift. There was multiple pulls in different directions to get it into its final position, which was quite awkward as well. So there was a fair amount of rigging studies involved as well. So late nights, running scenarios on AutoCAD, just to get it right, just make sure no failure. DCC Church, the arches consist of basically two parts. It's a main arch spanning across. I think that's about 71 meters. The arch length is 71 meters. Weighs in about 31 tons. That was erected in three parts. So two end parts connected to concrete abutments, and they then rested on temporary towers that we erected. Those towers were fully adjustable as well, so we could, if need be, hoist the end pieces up or lower them. And that was a particular reason for that, because we still had to install the final mid portion of that main arch, and to do so you need to make space. So purposely the end pieces were hoisted higher on the temporary towers to make space for the central piece. That was hoisted with two cranes, tandem lift, and once in position there were two rigging crews at each tower. They unjacked the jacking brackets, which brought the end pieces down until they came into contact with the mid portion of the main arch, and the whole thing was assembled, bolted together. So that was literally the easiest part of this project. And then it started with the sloping arches that you've always obviously seen, that cuts into the main arch. Those were a big challenge for us in terms of the actual rigging part of it. It was no longer a straight arch that just spans from point A to point B. It still did that, but the arch was tilted. It did that. So we realized that every sling that got attached to the crane and to the arch had to be of a different length. But not only that, in such a way that it induced the tilt, but also when you lift the sloping arch, the one end would stay well above the lower end, so that we could connect the upper end of it to the arch and the lower end to the abutment. That was quite a challenge, and in all honesty, the first lift there was some adjustment required, but after the first lift, the rest of the sloping arches just fitted perfectly. Well, the benefits of this particular structure as well, again, we're talking weight, we're talking time saving. Could this be done in concrete? I believe it could be, but I think the undertaking of doing it in concrete would have been absolutely enormous. Time consuming would be definitely a component to it. We managed to get this up quite quick. I mean, if you look at the main arch, it was done in 3 lifts. No curing time required. Once it was in and it was locked in place, that was it, done. We just needed to finalize it by installing a couple of cladding panels, which was done by HP Interiors, and off we went. So again, time is a factor, I think, and especially on this project where it was required to get this up as quick as possible, as safe as possible. Definitely steel is the way to go. It's light, it's strong, and quite serviceable. Most definitely the rigging crew. The crew that we had there, they're exceptionally good riggers, especially when it comes to singular lifts, like we had to take care of on site. They follow exactly, look, in this particular project, the thing that I did enjoy is the rigging studies that I drew up were followed to the letter, and that helps a lot. It helps a lot. I think you cannot afford having entities on site that might deviate. And within Martin and Chris to that confidence that it would be followed to the letter, and they did so, and I think it's part of the reason why you see the structure sitting the way it does. It's solid, it's safe, and I think well executed. So most proud of, we are definitely my rigging crew.